Good morning, class. Before anything else, let us first ask for guidance from our Heavenly Father. Leo, could you please lead a prayer? Amen. Thank you, Leo. So, how are you guys doing today? Nice, good to hear that. But I want to know how you are feeling at this very moment. So, please, everyone, kindly type big letter H in our chat box if you feel happy today. If you're a little bit lonely, kindly type big letter S. If you're nervous, type big N. Or if you're not interested in today's discussion and feels a little bit bored, type B. I'm being flooded with letters. So let me see your responses. Most of you sent H. That's good. Well, I can also see that some are nervous. Why? Because of our new lesson today? Don't get nervous, alright? Well, before we start with our lesson, allow me to share with you our house rules for this class. First, I want your microphone to be kept muted to avoid distractions, especially during the discussion proper. Is that clear? Okay, second, if you want to answer or you want to say something, I want you to kindly press the raise hand button. Open your microphone as well as your camera, and then you can talk. Otherwise, you can use our chat box for your answers or queries. Clear? Good. Third, keep your camera off unless you're answering, so it will not consume a lot of data. Lastly, please listen and participate in class. Are we all good? Thank you. Okay, so for our attendance this morning, kindly fill up this Google form. I sent the links to the chat box and you have a minute to fill up the form. When you are done, please type 1 in the chat box. So it turns out that 25 students are present today. Perfect attendance, that's great. So let's start learning. In our previous topic, we had discussed the electronic structure of matter. Am I right? Yes, now I have a simple game for everyone. It is called Pick a Door. In this part, well, you just need to pick the door you want, okay? And each door has a surprise question that you need to answer. Let's start. Okay, who wants to try first? Yes, Leo. Which door do you want? Number 2. Okay, the question is, atoms are made up of 3 small particles. What are those? Yes, proton, electron, and neutron. Very good, Leo. Another who wants to try? Yes, Angel. Door number 1. Okay, your question is, what is the substance that cannot be broken down into any other substance? Very good. That's electron. Thank you, Angel. Well, it seems that you guys already learned a lot from our previous discussion. That's great. Now, what we are going to do is we will explore a new topic. And to introduce our lesson for today, I have here another simple game for you again to give some hints about our next discussion. I bet you're all familiar with the game 4 picks 1 word, correct? Yes, very good. For those who aren't aware, it is a word guessing game, alright? It presents you with 4 pictures and then tasks you with guessing what a specific word fits with the theme of the photos presented. Are we clear? Okay, thank you. I want you to analyze the pictures, and if you know the answer, just press the raise hand button or type your answer in the chat box. Let's start. Here's the first group of pictures. John, are you raising your hand? Okay, go ahead. Very good. The pictures are all about compounds. Next. Yes, Leo? Absolutely. They are ionic compounds. Very good. Another one. Yes, Angel? Covalent compounds. Yes, that's right. Okay, so our lesson for today is about physical properties of ionic and covalent compounds. And here's the learning objective. Recognize different types of compounds, ionic or covalent, based on their properties such as melting and boiling point, hardness, polarity, and electrical and thermal conductivity. Now, let us proceed to the proper discussion. Do you have any idea what a compound is? I know your previous science teacher already discussed this. What can you remember? Yes, Angel? Very good. A compound is made up of an ion. If that's the case, what is an ion then? Yes, John? Your answer is correct. An ion is composed of a positively and negatively charged atom. What do we call these 2 charges? Yes, Leo? Excellent. Cation and anion. You can still pretty much remember these things from your previous chemistry. That's great. Moving on, our first lesson is about ionic compounds. What is an ionic compound? Any guesses? Yes, Leo? Absolutely. Transfer of ions. Anyone who wants to read the definition of ionic compounds? Yes, Angel? Thank you. Okay, class. Based on what Angel has read, ionic compounds are made up of ions, okay? Held together by ionic bonding. Remember that. Now, I want you to look at your periodic table. We have metal and non-metal groups there. Do you have any idea at which part we can see the metals and the non-metals? Yes, John? Very good. Metals on the left and nonmetals on the right. Now look at your screen. I have a periodic table showcasing the metals, nonmetals, and metalloids. As you can see, metals are those blue in color, nonmetals are the gold ones, and metalloids are those in green. You can take a screenshot of this, okay? Or you can just use your periodic table if you have one there, because we need this later on in the discussion. Now, there are elements in your periodic table that when being combined can form an ionic compound. Let's see some of them. First one is sodium and chlorine. These two are in your periodic table, right? Okay, when we combine these two, we can be able to form a new chemical called sodium chloride or table salt. Another example is magnesium, hydrogen, and oxygen. When we combine these three, we are able to produce what we call magnesium hydroxide or milk of magnesia as it is commonly called. Another example are the minerals and rocks. Minerals are mostly ionic compounds because they give up one or more electrons to an adjacent atom. Now, how did we say that sodium chloride, magnesium hydroxide, and some minerals and rocks are all ionic compounds? It is because of this condition. Ionic bonds form between a metal and a nonmetal. Remember that. Ionic is between metal and nonmetal. Now let's go back to your periodic table. Leia, why did we say that sodium chloride is an ionic? Yes? Yes, very good. It is because sodium is a metal and chlorine is non-metal. How about magnesium hydroxide? Yes, Angel? Absolutely, that's right. Magnesium is metal, whilst oxygen and hydrogen are both non-metals. Very good. Let's consider some more examples of ionic compounds at home and their practical uses. First one is potassium iodide, which is a combination of potassium, a metal, and iodine, which is non-metal, forming a chemical formula of Ki. Do you have any idea what a potassium iodide is being commonly called? Yes, John? Very good. It is a metal halide salt. The next one is sodium fluoride, a combination of sodium, which is metal, and fluorine, which is non-metal, forming a chemical formula of NaF. Do you know where we usually find sodium chloride? Yes, Leo? Absolutely, in our toothpaste at home. Next, we have sodium carbonate, a combination of sodium, which is metal, and carbon and oxygen, which are both non-metals. Do you know what the common name for sodium carbonate is? Yes, Angel? Very good. Washing soda, which is being used as a cleaning agent. We also have sodium hypochlorite, a combination of sodium, which is metal, oxygen and chlorine, which are both non-metals. Do you have any idea what a sodium hypochlorite is? None? Okay, sodium hypochlorite is our bleach at home, which is an excellent disinfectant or antimicrobial agent. Next is sodium hydroxide, a combination of sodium, which is metal, oxygen and hydrogen, which are both non-metals. What is sodium hydroxide's common name? Any idea? Yes, Angel? Absolutely. It is caustic soda being used in the manufacture of pulp and paper, alumina, soap, and detergents. We also have calcium carbonate, a combination of calcium, which is metal, carbon and oxygen, which are both non-metals. Do you know what's the common name for calcium carbonate? Yes, John? Very good. Calcium carbonate is also known as chalk, which is widely used in plastics, paints, and paper. Next is the magnesium sulfate, a combination of magnesium, which is metal, sulfur and oxygen, which are both non-metals. Do you have an idea what a magnesium sulfate is? None? Okay, magnesium sulfate is also known as Epsom salt, which is used to control low blood levels of magnesium. Lastly, we have sodium hydrogen phosphate, a combination of sodium, which is metal, hydrogen, phosphorus, and oxygen, which are all non-metals. Well, this one is used in powdered products where it acts as thickening agents and leavening agents for baked goods. Do you have any questions? The lesson is clear so far? Okay, very good. If that's the case, I will show you pictures where you need to analyze which is metal and non-metal in each of the compounds that I am going to present. Are we clear? Okay, thank you. The first example is this iron 3 chloride. Who wants to answer? Yes, Angel? You're raising your hand? Precisely. Iron is the metal, while chlorine is the non-metal. Another example, we have copper 2 phosphate. Yes, John? Very good. Copper is the metal, while phosphorus and oxygen are the non-metals. Next, who wants to answer? Yes, Leo? Absolutely. The metal is the aluminum, while the non-metals are the oxygen and the hydrogen. Do you have any questions or clarification in this part? None? Very good. You guys are doing great. Now, let's proceed to the next topic, which is the covalent compounds. Do you have any idea what covalent compounds are? None? That's okay. Let me explain to you, class. Covalent compounds are a chemical bond involving the sharing of election pairs between atoms. These election pairs are known as shared pairs or bonding pairs. Covalent bonding is the stable balance of attractive and repulsive forces between atoms when they share electrons. From this definition, anyone who can tell me the difference between an ionic and covalent compound? Yes, Angel? Very good. In ionic compounds, we have transfer of electrons, whilst in covalent compounds, we have sharing of electrons. Consider a family reading a book together. Election sharing is similar to this, okay? The family members will not learn anything new if someone from them does not share knowledge. For example, I am reading something from my favorite book, and one of the topics there is about how to maintain calmness. Do you think my siblings or even my parents would know such information if I did not share with them what I just read? Yes, that's right. They wouldn't know unless I give them the exact information from that book. It's similar to an election. If you don't share it, it will not stay stable. Look at this illustration. It's another example of how covalent compounds work. In picture A, the two puppies, the orange and the purple, represent atoms. Now the bone in their mouth represents their own electrons. So the orange puppy has its own bone or electron in its mouth. Same goes with the purple ones. Now in picture B, they shared both their bones or electrons. Orange puppy, while sharing his electron to the purple one, will have an access to purple's puppy's electron, and vice versa. Is it clear? Do you understand? Okay, that's good. Now, to better understand what I am saying, let's use a real model showcasing the sharing of electrons. This one you're seeing on your screen shows one oxygen atom and two hydrogen atoms. As you could observe, one of the electrons of oxygen got paired with one electron from the hydrogen. And since there are two hydrogens, all in all, two electrons of oxygen got bonded with the electrons of each of the hydrogen atoms. Is it clear? Do you have any questions? None so far? Okay, let's move to the types of covalent compounds. As you can see here, we have two types of covalent compounds, the polar covalent and the non-polar covalent. Let's differentiate the two. Anyone who wants to read the definition of polar covalent? Yes, Leo? Thank you. So, in polar covalent, electrons are being shared unequally. Alright, remember that, class. If an equal sharing of electrons, that is polar covalent. How about non-polar covalent? Who wants to read? Yes, Angel? Thank you. So, it turns out that non-polar covalent is the opposite of the polar ones, because here, electrons are being shared more or less equally. Remember that. Non-polar, again, does not want to have an unequal sharing of electrons. Is that clear? Did you get the point? Okay, very good. Now, I want you to remember this. Covalent bonds usually form between nonmetals. So, who can tell me the difference between ionic and covalent bonds in terms of the elements involved? Yes, John? Absolutely. In ionic bonds, we have metal plus nonmetal. Here in covalent bond, we have nonmetal plus nonmetal. Now, let's see some examples. For the first one, who wants to read? Yes, Angel? Thank you. In this example, we have H2O or water. Anyone who can tell me what are the two elements involved in water molecules? Yes, Leo? That's right. We have hydrogen and oxygen. Are these two both nonmetals? Yes, very good. They are both nonmetals. Therefore, what kind of bond is present? Covalent bond, that's right. Now, take a look at the illustration. How many electrons did oxygen share all in all? Absolutely. Oxygen shared two electrons, one for the first hydrogen atom and another one for the second hydrogen atom. Now, for the first hydrogen atom, how many electrons did it share with the oxygen? Yes, it only shared one electron. The same goes with the second hydrogen atom. Was there an equal or an unequal sharing of electrons? Yes, Leo? Very good. Electrons were being shared unequally. Therefore, what type of bond is present? Yes, John? Perfect. Polar covalent bond. Do you now understand? Very good. Let's consider example number 2. Who wants to read and explain? Yes, Angel? Excellent explanation. Nitrogen and hydrogen are both nonmetals. That's why ammonia is a covalent compound, correct? Also, 3 electrons of nitrogen atom were being shared to the hydrogen atoms, and the hydrogen atoms, in turn, only gave 1 electron each. Thank you, Angel. Now, for our third example, we have ethanol or C2H5O. The hydroxyl group linked to the carbon end of ethanol makes it polar. The hydroxyl group becomes polar due to the electronegativity difference between oxygen and hydrogen atom. The ethanol molecule then develops a non-zero dipole moment and becomes a polar molecule. Now, if we look at the periodic table, we will see that carbon, hydrogen, and oxygen are all nonmetals, right? Okay, if they are all nonmetals, then what are they? A covalent compound. Very good, John. Ethanol is a covalent compound. What type of covalent compound then? Based on this description, ethanol is a polar molecule because of something we called an electronegativity difference. So it turns out that we also have another way on how we can determine whether a covalent compound is polar or non-polar. But before that, let us consider the fourth example. Look at the image on your screen. What compounds are present? Yes, Leo? Very good. We have sulfur dioxide and nitrogen oxide. Are they ionic or covalent? Anyone? Yes, Angel? Perfect. They are covalent compounds because sulfur, oxygen, and nitrogen are all nonmetals. Now, sulfur dioxide and nitrogen oxide are gases that react easily with other substances, forming detrimental compounds and falling as acid rain. Now, where are these compounds coming from? These compounds are emitted from fuels, power plants, smoke, vehicle exhaust, among others, and give hazards to human health and other living forms. Nitrous oxide, also known as laughing gas, contributes to the world's greatest problem, which is global warming. Activities are all by human means, right? Now, how do you think we can help to lessen these activities? Okay, we have messages in the chat box. Leo said we need to reduce car air conditioner usage. That's right. According to Angel, smoke can be reduced by using oil or gas instead of coal in factories and riding a bicycle or walking instead of driving. Absolutely. And John said turning off the lights and appliances when they are not in use. Yes, that's right. All of your answers are correct. Do you have any questions? None? Okay, let's move to the physical properties of compounds. Anyone who wants to read? Yes, Angel? Thank you. Angel did mention the different physical properties of matter. Let's talk about them one by one. First is the melting point, or the required temperature to melt a solid. It also determines how pure a substance is. Can you give me some examples of things that can melt? Okay, we have messages in the chat box again. You guys said ice, cheese, sugar. That's right. Second is the boiling point, or the temperature at which a liquid's vapor pressure matches the pressure around it, and the liquid transforms into a vapor. What's the best example for this boiling point? What do you think, class? Okay, Leo said a boiling water. That's correct. Water boils at 100 degrees Celsius. But not all liquids do boil at that temperature, remember that. Some boil at a lower temperature, while others need a higher temperature to boil. Third one is hardness or rigidity, which depends on the attraction between the positive end and the negative ions of the compounds. Class, an example of this is salt. When you crush the table salt, what do you think will happen? It cracks and breaks, correct. But how about a diamond? Can you crush it? Definitely not, because diamond is harder than a common salt. Fourth example is conductivity. Take note of this, class. Ionic compounds are conductors of electricity when molten or in solution, and insulators when solid. Covalent compounds, on the other hand, are almost always good insulators of both electricity and heat because there are no ions to move the electrical charge. Remember that. Ionic compounds are conductors when molten and insulators when solid, while covalent compounds are almost always good insulators. Now, for the fifth one, we have polarity. Remember we talked about an electronegativity difference a while ago, right? Yes, we will discuss that here. Polarity is the physical property that talks about the pull or the attraction of an ion towards each other, which is determined by its electronegativity. Now, in order for us to determine the polarity of a certain compound, we need to compute for its electronegativity difference. Don't worry, it's just very easy, and I bet you can answer these even without your calculator. All you need is your periodic table. Now, what is the general rule in computing for electronegativity difference? Say, for example, you already have a certain compound. Now, the first thing you need to do is look at your periodic table. Determine the electronegativity of the elements involved in your compound. Upon identifying their electronegativity, subtract them, and what you will get is the answer. Is that clear? Okay, let's see. For the first one, we have sodium and chlorine, or yes, sodium chloride. Now, what is the electronegativity of sodium? Yes, John? Very good, 0.93. How about chlorine? Yes, Angel? That's right, 3.16. Now, using our general rule, what would then be the electronegativity difference of sodium chloride? Yes, Leo? Perfect, 2.23. Now, I want you to take note of this. If the electronegativity difference is less than 0.4, it is non-polar covalent, okay? If the electronegativity difference is between 0.4 and 1.8, it is polar covalent. If the electronegativity difference is greater than 1.8, it is an ionic compound, okay? Less than 0.4, non-polar. Between 0.4 and 1.8, polar. Greater than 1.8, ionic. Are we clear? Very good. Let's go back to the first example. Sodium chloride has an electronegativity difference of 2.23. So, what is it? Yes, Angel? Very good. NaCl is an ionic compound. Second example, we have sulfur and oxygen, or yes, sulfur dioxide. So, what is the electronegativity of sulfur? Yes, Angel? Correct. That's 2.58. How about oxygen? Yes, Leo? Perfect. 3.44. Based on this given, what is now the electronegativity difference of sulfur dioxide? Very good. That is 0.86. Polar, non-polar, or ionic? Absolutely. Sulfur dioxide is polar covalent. Next one, we have carbon and hydrogen, or yes, methane. Anyone who can give me the electronegativity of both carbon and oxygen? Or hydrogen, rather. Yes, John? That's correct. For carbon, 2.55, and for hydrogen, we have 2.2. Now, John, what is the electronegativity difference of methane? Very good. That's 0.35. Polar, non-polar, or ionic? Non-polar, exactly. Do you still observe what we are discussing? That's great. You don't have any questions so far? Okay, for now, let's have a 5-minute break. Move your arms and feet. Go get water if you're feeling thirsty. Those who want to use the restroom, I am giving you time. Okay, so to summarize our lesson in ionic and covalent compounds, kindly watch this short video. Okay, may I know your key takeaways from the video you just watched? Yes, Angel? Go ahead. Thank you, very good. How about you, Leo? Precisely, thank you to both of you. Now, to evaluate your understanding, I am requiring everyone to answer these simple questions. All you need to do is to comment a thumbs up if it is okay, and comment a thumbs down if it is too hard to understand. Are we clear? Good. I find today's lesson interesting. Wow, lots of thumbs up here. I can explain the physical properties of compounds. That's great. I can differentiate ionic compounds from covalent compounds. There are lots of thumbs up, very good. I can compute the electronegativity differences of different compounds. Excellent, thank you, class. So for your pair activity, I'd like you to pair up with someone from this class. However, because we're just conducting a virtual class, I would like a pair of boys and girls. It wouldn't be that uncomfortable, would it be? Okay, for your pair activity to be submitted until next week, I want you to access the PhET interactive simulations. You can open it in either your phone or in your PC, Although I will post the instructions in our Google Classroom, let me give you an overview. What you will do is you'll build a molecule. Together with your partner, build as many identifiable molecules as possible. Then tell whether each of the molecules you have built is ionic or covalent. Is that clear? Do you have any questions? For your pair activity, I will post all the instructions in our Google Classroom step by step, don't worry. Are we clear? Are you sure you don't have any more questions? If that's so, kindly open your camera. We'll just take a screenshot real quick. Okay, 1, 2, 3, say cheese. Alright, so thank you for your participation. I hope you learned a lot from the discussion. If you have any questions, clarifications, or violent reactions, you can always reach me through Facebook Messenger, or you can also send me an email. So that's all for today. Goodbye, class.